before midterm exam. And this is combination of concept, but some of the discussion that we will have in the compressor was already, or yung mga competition natin is yung ilan uh, discuss na natin in the previous week. So, meron lang din na konti, mapapadagdag na yun. So, before we start our discussion, I will be showing you an animation presenting yung standard vapor compression cycle para at least, magkaroon kayo ng basehan. Baka yung iba naman napanood na din 'to, baka yung iba nanood din kung paano gumagana yung vapor compression cycle. Play lang din natin ngayon.
Subscriptions just to get one design project done? Stop wasting time.
Welcome to Academic Gain Tutorials. In this video, we will learn about the vapor compression refrigeration system, along with its different parts and functions. So, let's get into the topic. We know that refrigeration is the process of lowering the temperature by removing unwanted heat from a selected object, substance, or unenclosed space and transferring this heat to another object, substance, or space. Now, from the name vapor compression refrigeration system, we can understand that in this process we will compress a vapor refrigerant inside the system to obtain the refrigeration or cooling. If we are going to compress vapor in this system of refrigeration, then obviously we will need a compressor for this job. So, the process of compressing the vapor refrigerant inside the system using a compressor to obtain the refrigeration or cooling is called vapor compression refrigeration system. Now, let's look into the major parts and components, and basic working procedure of the vapor compression refrigeration system. So, here we have a compressor, after that there is a condenser, then there is an expansion valve or throttle valve, or we can simply call it a valve, and finally, there is an evaporator. So these four major components together construct the vapor compression refrigeration system. All these components are connected together using these connecting pipes, thus a closed-loop system is formed, and the refrigerant for this vapor compression refrigeration system will flow through all these components and pipes in the system. Now, let's see how these components work. Throughout the whole process, our main purpose will be to ensure that continuously cooling effect or refrigeration effect is obtained in this evaporator. We all know that this evaporator is the component where the refrigeration or cooling actually takes place. This evaporator is placed on the region where we need cooling, and then the evaporator absorbs all the heat of that region and passes those heat to the cold refrigerant passing through the evaporator coils, thus the surrounding environment cools down. So, let's see how this process works. First of all, this compressor starts working. The job of the compressor is to pressurize or compress the vapor refrigerant inside this compressor chamber. Here, in vapor compression refrigeration system we commonly use either ammonia or freon as a heat-carrying medium throughout the whole procedure. Now, we know that if pressure increases, it also increases the temperature. So, when this vapor refrigerant is compressed inside the compressor chamber by squeezing the vapor very tightly together, it will heat up. After that, this high pressure and high temperature vapor refrigerant will leave the compressor and will enter into the condenser through this connected pipe. Here, we have a condenser. When high temperature high pressure vapor refrigerant enters this cold condenser, then the condenser absorbs the heat from the vapor refrigerant, and completely converts it into liquid. This condenser can be water-cooled, air-cooled, or cooled by any other substance from an external source, which will liberate the latent heat of this vapor coming into the condenser, and thus condensing keeps happening. So, in easier words, condenser changes the incoming high temperature high pressure vapor refrigerant into liquid state by changing its phase. Here we had vapor coming in, and now we have liquid refrigerant going out, so the phase is changed. Now this high pressure high temperature liquid refrigerant will leave the condenser, and pass through this expansion valve or throttle valve using this connected pipe. Now, this high pressure liquid refrigerant coming from the condenser will be expanded inside this expansion valve. We know that when expansion occurs, the pressure between the molecules decreases considerably, thus the temperature falls. So, this high-pressure liquid refrigerant will be expanded into low-pressure, low-temperature liquid refrigerant. In practical use, at this point we do not get only liquid refrigerant, but here we actually obtain a mixture of low-pressure, low-temperature liquid and vapor refrigerant. Thus, here we get a mixture of very cold, chilled, low-temperature liquid and vapor refrigerant coming out of the expansion valve. Then, this liquid and vapor mixed refrigerant will be passed over to the evaporator. We all know that the main cooling effect or refrigeration effect always occurs in the evaporator. So, when this low pressure, very cold, chilled, low temperature liquid refrigerant will enter the evaporator coils, it will absorb all the heat present in the surface of the evaporator coils. By absorbing all the heat from the surrounding region of the evaporator coils, this cold chilled liquid refrigerant will completely turn into low pressure vapor refrigerant inside these coils, and the surrounding region of the evaporator will become cold by losing the heat to this liquid. Thus the cooling effect or refrigeration effect has occurred in the evaporator. After that, this low-pressure vapor refrigerant will leave the evaporator and enter into this compressor through this connected pipe. Now, this low-pressure vapor refrigerant coming to the condenser will be again compressed inside the compressor chamber and converted to high-pressure high-temperature vapor. Then again this high-pressure high-temperature vapor will be passed to this condenser where it will change phase and will be converted to liquid. Then it is passed to the expansion valve, the evaporator and again to the compressor, so the cycle keeps repeating over and over again, and refrigeration or cooling is obtained continuously in the evaporator region throughout the whole process. So, this is how vapor compression refrigeration system works. Thank you for watching this video. If this video was helpful, subscribe to my channel Academic Gain Tutorials for more updated videos.
Okay. Okay, malinaw naman 'yun? Clear? So, na-discuss din naman natin last previous weeks, standard vapor compression cycle and the actual vapor compression cycle also is working that way. So pinagkaiba lang is that minsan nagkakaroon tayo ng superheating and subcooling. So sa actual, you have to also consider then the pressure drop in each of the in each component, like in the evaporator and condenser. So before pala we move on to this topic, I will also show another video, just medyo mas mahaba dun sa una. So this is a slight introduction of the compressor. Then, okay, wait.
Video is going to be about compressors, and actually you can see back behind me here. All right, this video is going to be about compressors. And just a couple of them that you'll see. Reciprocating is traditionally one of the most common. Rotary compressors are for generally smaller units. Scroll compressors are more and more common nowadays in both refrigeration and in air conditioning. And then you also have some larger compressors known as screw compressors and centrifugal compressors, and you're typically going to see those in very large applications. Those are the typical 5 types, but they all work in similar ways, and their job is to compress The compressor's job is to compress. Imagine that. Vapor refrigerant. And vapor means it is not in the liquid state, it is in the vapor state. So it is fully vapor. All of these compressors are designed to compress complete vapor. All compressors decrease the volume that the refrigerant is in order to increase the pressure. That's what it does. It decreases the volume, the space that the refrigerant is in inside that compressor, which then increases the pressure and causes it to move. Because we know high pressure goes to low pressure. That's one of my basic rules. And so the compressor creates that difference. Now, where does the compressor get the energy from? Well, most compressors nowadays, they have electrical plugs right on them, and they're generally a material called fusite. It's like a glass plug that you make these electrical connections, and the electricity is allowed to pass through the shell. But once it gets inside the shell, the refrigerant and the motor and the compressor are all there on the inside. That's the most common type. There are compressors that can be accessed through a series of bolts that can be removed, and those are called semi-hermetic compressors. There are compressors that are completely sealed, that they're not designed to be accessed at all. The only way to get into them would be to cut them open, and those are called hermetic compressors. And then an older type of compressor that's still out there in certain applications is called an open drive compressor. And in an open drive compressor, rather than introducing energy into the compressor via electricity through a fusite plug, instead you actually drive a shaft. And so you have the compressor is a separate component from the motor. So you actually connect a separate motor to the compressor. Those are rare because you have a shaft that's coming out of the compressor, and that is very likely to have leaks on it. And so it's a really common issue with open drive compressors when they were common, and so now they've gone to mostly sealed, whether semi-hermetic or hermetic. So as we mentioned, they all function by pumping vapor, but a really important thing with compressors is that when we are setting up a system that we're only feeding it with vapor. So this is why we test something that we call superheat. It's a term that you hear a lot in air conditioning. It's one of the reasons why we measure it is so that we can ensure that all of the refrigerant that's entering the compressor is fully vapor, because if we get liquid refrigerant into that compressor, it can cause damage if it gets up to the head, the part that actually does the pumping. So that's very critical. Another really critical thing with compressors is that we get the temperature right. So the temperature of that suction gas that's coming into the compressor needs to be the right temperature and at the right mass flow rate in order to keep that compressor cool if the compressor is refrigerant cooled, which is by and large the most common. There are two different types of compressors, air cooled and refrigerant cooled, but for most of the industry, we're typically using refrigerant cooled compressors, which means that the refrigerant that enters the compressor is actually what's doing the cooling of the compressor and the motor, cooling those internal parts. And so if the refrigerant coming into the compressor either is too hot, the temperature is too high of the refrigerant, or if the mass flow rate of the refrigerant, meaning the amount of it that's moving through the compressor, is too low, then it can't cool the compressor. I identified a couple things here. First, compressors pump vapor, so we can't bring liquid into the compressor. Secondly, we have to make sure to control the temperature and the mass flow rate, the amount of refrigerant coming down that suction line, entering the compressor, in order to make sure that it stays cool. There's another thing that we talk about a lot with compressors. It's called compression ratio. And compression ratio is just the absolute discharge pressure divided by the absolute suction. Basically, all that means is how much is it needing to increase the pressure. When that compressor has to increase the pressure to a higher degree, there's more waste because there's more re-expansion of the high pressure gas coming out of it. That's all fancy talk to just say that when a compressor has more work to do, it has to increase that pressure from a lower base pressure to a higher pressure. That differential is greater, then that compressor is going to do less work and it is going to run hotter, so higher temperature. And so those are all factors that we have to consider with a compressor. You throw that compression ratio factor in there as well. Oil control is really huge with compressors because the compressor has oil inside that crankcase, and at least in most cases. It's going to have that oil inside that crankcase. There is a compressor that actually uses magnetic bearings out there, which is pretty cool. But most compressors use typical bearings and they need to have oil lubrication. And so a small amount of oil is circulated through the system with the refrigerant, but the bulk of it should be in that compressor shell. But there's a couple different factors that can cause problems with that oil. One is if we do have liquid refrigerant coming down the suction line into that compressor, it can cause foaming and loss of oil, loss of viscosity of the oil. Another factor is if the compressor overheats, it can break down the oil. That's another thing that we look for, and another reason why we've got to make sure control that compressor temperature. But there's another factor, which is what we call flooded starts. And that's where liquid refrigerant migrates to that compressor during the off cycle, especially if the compressor's in a cold environment, say it's a split system and it's located outside, and that liquid refrigerant gathers in the oil. And then when that thing finally turns on, it creates a little mini explosion in there, and a lot of the oil is lost as that liquid refrigerant begins to boil. So that's another thing that we look for. We want to make sure that we don't have flooded starts in compressors. And that's where we use things like solenoids and pump down solenoids and compressor crankcase heaters and hard shut off TXVs. Those are all strategies that are used by manufacturers in order to prevent flooded starts. But let's get down into the nitty gritty of what the compressor does and how it fails. We talked about how it pumps vapor, but it takes vapor from the suction line down that suction line. It enters the compressor and then it pumps it up and it goes in the discharge line. And then from there, it goes into the condenser. Let's think of how to think about this, because you'll notice that the suction line coming into the compressor is low temperature and the discharge line leaving the compressor is high temperature. If you touch one and then the other, you're going to notice there's a big difference in temperature. I don't suggest that you go touching a discharge line because you can burn your hand, but there's going to be a big disparity in temperatures there. A typical air conditioning equipment running under normal conditions, you're usually going to see something like a 50-degree suction line temperature entering the compressor on that large line, and then coming out of the discharge line, you may see something like 165, 170. It's going to be pretty typical. And so that means that you have 120 degrees of increased temperature inside that compressor. One reason is that it's picking up a little heat as it cools the compressor itself and the motor and all those sorts of things. But another factor is, and the reason why we see the majority of that temperature increase is because when you compress something, when you take a mass and you compress it, those molecules bounce together more fast, more quickly. So higher velocity. Temperature, by its very nature, is average molecular velocity or average kinetic energy within a substance. And so when you take something that's in a higher volume and you compress it into a smaller volume, imagine it like a bunch of ping pong balls or a bunch of those little super bouncy balls that you used to get from the coin operated thing at the grocery store. And you take all of them and they're bouncing around and you start to force them together. Well, what happens? Well, they start to impart energy on each other as they're bouncing against each other and against the sides. And so because temperature by its very nature is average molecular velocity, when we force things together, we see an increase in temperature. Now, does that mean there's an increase in heat? Well, there is, because you have the increase of heat inside the compressor from the motor. The motor is electrical, it has windings, and so there's a little increase in heat. But largely, it's that it's not an increase in heat, it's only an increase in temperature, because all the heat that was absorbed in that evaporator coil and then maybe a little bit in the suction line when it was coming back. But we still notice that suction line is, say, 50 degrees. And now we force it together and now all of a sudden the temperature goes sky high. Well, the temperature goes sky high without a huge increase in the overall heat content, just by decreasing that volume, thereby increasing the pressure and the density. So when we increase the pressure and density, now we start to see an increase in temperature. And then it goes into the condenser, rejects that heat off, and that's how we turn it into a liquid. A compressor cannot turn vapor refrigerant directly to a liquid, because as we compress, the temperature increases, and so it won't allow it to condense. It has to go through that condenser, allow the heat to be rejected before it can actually become a liquid. A lot of technicians have this false sense that the compressor compresses liquid, and that just isn't possible without having that heat rejection that the condenser provides. So hopefully that was a good little introduction into compressors. There's a lot of different ways that they fail. We're not going to go into that right now, but we'll do that in a separate video, ways that compressors fail and how to diagnose them. This is just an introduction. Hope you enjoyed. We'll catch you on the next video.
Handog ng Bear Brand. Ang 840 grams, 300 pesos na lang. Mag-Bear Brand araw-araw.
Okay. So compressor is one of the most important components of the vapor compression system. Others, like condenser, evaporators, and expansion devices, has its own peculiar function that makes the system controllable. Since the compressor is the prime mover of refrigerant circulating the system, it is commonly known as the heart of vapor compression system. So we have here four most common type of compressor that is used in the refrigeration system, and some of this was discussed kanina. So we have the reciprocating compressor, screw, centrifugal, and the vane type. So for reciprocating compressor, can you please read this, Avniel?
Yung ano po ma'am, yung reciprocating compressor pa.
Ah,
Reciprocating compressor. The reciprocating compressor consists of a piston moving back and forth in the cylinder with suction and discharge valve, so arranged to allow pumping to take place. The workhorse of refrigeration industry is the reciprocating compressor, built in sizes ranging from fractional kilowatts to hundred of kilowatts of refrigeration capacity. Modern compressors are single-acting and may be single-cylinder or multi-cylinder. In multi-cylinder compressor, the cylinder are in V-type, double V-type, radial or inline arrangement. Okay na po, ma'am?
okay. So here is a video for a reciprocating compressor. So I know naman you're already familiar on how this works, but at least this is again a visualization.
Let's take a deeper dive into the reciprocating compressor. Our journey begins with the cylinder, the compressor's heart, where the refrigerant is compressed. Next is the piston, the workhorse that creates the pressure for the compressor to operate effectively. Driving the piston's movement is the crankshaft. Its rotation converts into linear motion, driving the back and forth action of the piston. The connecting rods act as the link between the crankshaft and the piston. It transfers the rotational motion of the crankshaft into the linear motion of the piston. And the spring keeps the entire system safe from potential damage and noise caused by vibrations during operation. Within the cylinder, as the piston retreats, it creates a low-pressure area. Responding to this pressure difference, the suction valve opens, allowing the refrigerant to flow into it. The piston then compresses the refrigerant, raising it up to a high pressure and temperature. As the refrigerant compresses, the suction valve closes. This prevents the compressed refrigerant from flowing back into the intake. Once the refrigerant reaches the desired pressure, the discharge valve opens, heading to the condenser where it releases the heat. And just like that, the cycle repeats. This efficient rhythmic process delivers a consistent flow of high-pressure gas. Ensuring smooth operation by reducing friction among these moving parts, our lubricating oil extends the lifespan of the LG reciprocating compressor. As the crankshaft rotates, it splashes the oil to the necessary parts. Some compressor designs may also incorporate a pump to aid in oil distribution. The refrigerant and oil flow through the reciprocating compressor in perfect harmony, each performing their crucial roles in this efficient, powerful system. Safety is a crucial principle to the design and operation of all LG compressors. The controller monitors the compressor's operation status, shutting it off if it gets too hot or is the status of excess pressure. It can protect internal components, protecting the system and preventing potential accidents. Together, they all play an important role in keeping the reciprocating compressor at peak performance in a safe, reliable manner.
All right, team, we're transitioning to FLAC, but tasks are still going to be on Bullfrog.
Did nobody see my poppycock post? There was no clapping.
Okay, so next we have here the screw compressor. Can you please read this, Yumi? Andiyan ka ba, Yumi?
Yes po. The screw compressors are rotary compressors that use rotating elements like a pair of screw inside stationary cylinders. This pair of screw provide positive displacements of gases on the discharge port of the compressor. Screw and small centrifugal compressor which battles for the market in the range of 300 to 500 kilowatts of refrigeration. Number 3, centrifugal compressors are compressors whose rotating elements operates to compress gases by virtue of centrifugal force. The centrifugal compressor is the choice for large capacity units, particularly for water chilling plants used for large air conditioning installation.
Okay lang, Neng. Tuloy mo na.
Centrifugal compressor are most widely used for units having refrigerating capacities of 500 kilowatts and above.
Okay, so let me show you an example of a screw compressor and then followed by a centrifugal compressor. So, kung mapapansin nyo, sa pagpili ng compressor, makikita nyo dyan what are the common refrigeration capacity, sizes that compressor can handle. So, nandiyan dyan naman yan sa mga specification of the material or of the equipment. Okay, so again, this is an animation of a screw compressor working principle.
MAN Diesel and Turbo manufactures tailor-made process gas screw compressors for customers, a modular system of tried and tested components guaranteeing the utmost reliability. Depending on its size, a compressor stage can suck in and then compress volume flows of between about 200 and 100,000 cubic meters per hour. All screw compressors operate according to the basic principle of a positive displacement machine, whose key element is a pair of spiral rotors. During operation, the rotors turn and the spiral teeth mesh together, forming chambers between the rotors and the casing wall. Rotation causes the chambers to move from the suction or intake side to the compression or discharge side. These chambers are connected to the suction nozzle via ports. As the chambers enlarge, they are filled with gas flowing in through the nozzle. To understand the compression process better, let's look at an individual chamber. It enlarges, is filled with gas, and then closed by a circumferential edge in the casing. The rotors now transport the gas to the discharge side, where the chamber shrinks and the retained gas is compressed. Let's view the process again, this time from below. Once the gas is compressed, the chamber reaches another port connected to a discharge nozzle, and the gas flows out. In fact, all the chambers between the two rotors are being filled and emptied continuously. This means that with a screw compressor, the compression process is more or less ongoing. The design of a screw compressor combines the advantages of a positive displacement machine with those of a rotating machine, making this type of compressor suitable for a very wide range of applications and process gases. MAN Diesel and Turbo has been developing and constructing process gas screw compressors at its Oberhausen location since 1952. It is one of the few companies worldwide which sells both oil-free and oil injection compressors for process applications.
Okay, so the next one, this is.
Are you juggling 10?
Let's examine the centrifugal compressor, which uses non-positive displacement vapor compression for compressing large amounts of refrigerant and are typically used in very large capacity cooling systems. A centrifugal compressor has three basic components: an impeller, a diffuser, and a volute casing. Large capacity centrifugal compressors may have two or more impellers or stages in the same casing. Centrifugal compressors are usually driven by hermetic electric motors. However, open-drive centrifugal compressors are also available for applications using steam turbine, gas turbine, or engine drives. The impeller is a rotating circular disc with curved blades that is driven at high speed by the electric motor. As the impeller rotates, it moves refrigerant vapor from the suction opening in its center to the outer edge using centrifugal force. The vapor enters the suction at a relatively low velocity and leaves the outer edge of the impeller at a high velocity. This means that the impeller transfers its rotational energy to the vapor, but high velocity does not relate to high static pressure. To achieve the desired pressure increase, or compression, the vapor must be slowed down, converting its velocity pressure to static pressure. That's where the diffuser comes in. As high-velocity vapor moves radially outward through the diffuser, the flow area increases, slowing the vapor and increasing the static pressure. Some centrifugal models have diffusers with vanes or pipes which change flow direction and further slow the vapor. The volute-shaped casing collects the slow-moving, high-pressure vapor from around the diffuser and conveys it to the discharge connection of the compressor. Inlet guide vanes control a centrifugal compressor's capacity. These movable vanes are located in the suction opening. With vanes turned fully open, the compressor produces its full cooling capacity. As the vanes are closed, they reduce refrigerant flow through the compressor, reducing the capacity of the refrigeration cycle. In addition, capacity control in a centrifugal compressor can also be obtained by changing the rotating speed. This concludes our segment on the mechanical non-positive displacement vapor compression cycle using a centrifugal compressor. Please.
Okay, next, can you please read this, Warren? Okay, so next we have the hermetically sealed compressors.
Hermetically sealed compressors are compressors whose motor and compressor are often enclosed in the same housing or common housing to avoid leakages at the seal. Improved techniques for insulating the motor electrically have allowed motor to operate even though they are in contact with the refrigerant. In many designs, the cold suction gas is drawn across the motor to keep the motor cool. Almost all small motor compressor combinations used in refrigerators, freezers, and residential air conditioners are of hermetic type. The only connection to the compressor housing are the suction and discharge fittings and electric terminals. Moisture in the system can be damaging the motor. Therefore, dehydration of hermetic units before charging refrigerant is essential. Condensing units are components of refrigeration system specifically arranged to combine with compressor in most split-type air conditioner refrigeration system. This unit is usually termed as outer unit of refrigeration system. The indoor unit consists of expansion valve and evaporator are located inside the room of a split-type air conditioner.
channel. In this video I discuss about hermetically sealed compressors, its component, its working, why its name is hermetically sealed, and its advantages and limitations and its applications. Now it's known hermetically sealed compressors because in a one unit, means this black unit, okay, it is constructed from the steel. Inside this complete unit we are putting the two component. One is the motor and second one is the compressor. This compressor may be reciprocating or a rotary types. Okay, so in one unit we putting the motor and compressors. That's why it is known as hermetically sealed compressors. Okay, and it is sealed on the one unit, so there is a no leakage problems. Now it is here you see the sectional view of the hermetically sealed compressors. Now here you watch, it is a electric motors and on the upper part it's the compressors, and here the schematic diagrams, here the compressor and it is the motor parts. Now this motor have the winding, that is a stator and rotors. So it is the motor rotor winding and it is the stator windings. Okay, now and it is a not a completely sealed motor, but its winding is open inside them. Okay, and in this we have the three pipes. One is the suction pipe that is supplied to this compressor. This part is the compressors, and in this figure it is shown as the reciprocating compressors. It is a crankshaft. On this crankshaft, first up this is the motor, okay, and this is the shaft of the motor as well as the compressors. On this same unit, same shaft, motor is installed and this compressor is installed. This is the crank, connecting rod, piston, cylinders and discharge refrigerant is supplied. And this service line of the compressor is also provided because of the first time of the chargings. And before charging of these refrigerants, the complete unit is doing the dehydrations. Dehydration means we are removing the moisture content from the systems. If the moisture inside and we feel the refrigerant, it's create the problem inside the system, so dehydration of the complete unit is required. Okay, so this the again these same figures. So here you can see that in the motor the copper tube winding is directly supplied. This winding is opens. Okay, when this motor is there in the completely sealed units, so motor is heated after sign. So how this heat energy is rejected? So this heat energy removed from this motor is absorbed by these oils. So it is known as the cooling oil, as well as the refrigerant from the evaporator is coming at the low pressure and the vapor state. So it is passing from the winding of this motor. So this refrigerant is also absorbed some heat. So it is not given in the book any, but it is practically when you observe these things by cutting off these sealed compressors. So its tube refrigerant coming from the evaporator is first passing from the motor. So what this refrigerant absorb the heat from the motor and refrigerant superheating is also done. Then after it is supplied in the compressors, and in the compressors processes takes place and then it is supplied into the discharge line and then it is going into the condensers. So it is the complete workings of the hermetically sealed compressor. Next we see its applications. So it is widely used smaller capacity refrigerating system, such as used in domestic refrigerator, home freezers and window air conditioning system. So at our home in the fridge and AC, this compressor is used, that is a hermetically sealed compressors. That is a motors and compressor may be reciprocating or a rotary. Next its advantages. The leakage of refrigerant is completely avoided. So if leakage is done inside this compressor, it is also on the sealed. So leakage is not a problem. It is a less noise operations because motor is completely sealed by using the steel materials. So its noise is also come lower. The lubrication is simple as the motor and compressor operate in a sealed space with the lubrication oils. Next one, it's required a less space because when we separating install the motors and compressor, it required a larger space. Next, the disadvantages. There is a maintenance is difficult because of the moving parts are not assemblable. If there is a certain problem in the motor, then we also need to replace the compressor. If the problem in the compressor, then we also need to replace the motor. So increase our the maintenance cost as well as the maintenance is difficult because we are required to completely replace the parts. We are not doing the maintenance either motor or a compressors. We need to replace it. And second is for charging and evacuation, separate pump is required. For charging of this refrigerant from the service lines, we are required a separate pumps. Thank you for watching this video. If you learned, then like my video, subscribe my channels and share with your friend.
You want great hair? Pero tututsyang-tutsyang. May sagot right here. New
Okay. So those are some of the 4 types of the compressor that is commonly used in the refrigeration system. So for us to continue, we'll be discussing also how are we going to check or compute for the compressor performance. So in dealing with compressors performance, sa refrigerating capacity and compressor power requirement are the most important performance characteristics of evaluating compressor. So again, ang tinitingnan natin are the refrigerating capacity and compressor power requirement. So these two characteristics of the compressor operating at constant speed are controlled largely by the suction and its discharge pressure. So again, dun sa inlet and outlet of the compressor. An analysis will be made first of an ideal reciprocating compressor because it's a clear understanding of the effects of these two pressure. So trends established from study of the ideal compressor hold true for the actual compressor, although adjustment must be made in the numerical quantities. So this adjustment will be examined in the discussion of the actual compressor. So the performance of the reciprocating compressor are being predicted by its volumetric efficiency. So the two types of the volumetric efficiency are the actual volumetric efficiency and the clearance volumetric efficiency. So for the actual volumetric efficiency, this is the ratio of the actual volume flow rate entering the compressor and the volume swept through by the piston in their suction stroke per unit of time. So yung ating actual volumetric efficiency is equivalent to V1 over VD kung ang ginagamit natin na numerical subscript dun sa pH diagram natin is that yung inlet ng compressor natin is at state point 1. So dito, VA represents the volume flow rate entering the compressor. Yun lang yung wag nyong kakalimutan. Divided by VD or the displacement rate of the compressor. So that is V1 over VD. So next that we have here is the clearance volumetric efficiency, and it depends upon the expansion of gas trapped in the clearance volume. So here are the following formulas that you can also use in dealing with the clearance volumetric efficiency. So most of the values or formulas here was used already last week, no? So this is just a review. Where M is the percent clearance, C is the clearance volume, P sub D is the discharge pressure, P sub S is the suction pressure, and N is the compression index. So yan naman is naka V1 over V2 yung volume natin, and then yung ating pressure naman since discharge siya, so P2 over P1 raised to 1 over N. So kung mapapansin nyo based on last week na sinolve natin, we equated the volumetric efficiency and the clearance volumetric efficiency to get the volume displacement. But kung mapapansin nyo, magkaiba naman yung formula niya. So paano natin siya in-equate? So there is a relationship between the actual and clearance volumetric efficiency. The actual volumetric efficiency is equivalent to clearance volumetric efficiency multiplied by N sub S. Where N sub S is equal to PC over TC times TS over PS. So if this is not given, we assume that this efficiency is equal to 1. That's why we equate the actual volumetric efficiency to the clearance volumetric efficiency. Okay? Malinaw ba tayo doon? Can you please thumbs up kung clear tayo doon? Okay. So next that we have here are the thermodynamics work of compression. So most of the formulas in here was already again used last week. So meron lang tayo ditong additional which is the isothermal compression, but none of the compression process that we discussed for refrigeration system undergone isothermal compression. So we'll focus on the isentropic work of compression and for polytropic compression. So magkaparas lang naman yung formula niya, magkaiba lang yung isentropic compression index and the polytropic compression index. So same lang yan, but you have to take note that if we are in SI unit, tapos kilowatt yung kalalabasan na work, so dapat yung PS natin is in pressure is in kPa and the volume is in cubic meter per second. So yun yung wag niyong kakalimutan. Okay, so take note naka per second. unless ang hinihingi doon sa work is per kilogram. So, kaya kailangan niyo pa din mag-unit analysis palagi. Okay? So, this is an example of checking the performance of the ideal compressor. So, in the ideal compressor, the compression of gas and the re-expansion of gas trap in the clearance volume are both isentropic. The only factor that influences the volumetric efficiency of the ideal compressor is the re-expansion of gas trap in the cylinder head of the ideal compressor. So to show the effect of temperature on clearance volumetric efficiency, we're going to apply our data with the performance of ideal refrigerant 22 compressor, displacement rate of 50 liter per second at 4.5 clearance, and 35 degrees Celsius condensing temperature. So in order for you to practice the calculations capabilities, so ito naman is fill out na, but you can try this at home, dyan. At we will discuss, sabi, what is the relationship of the temperature to the volumetric efficiency. So this is solved problem na, but again, yung pag-solve naman ito is same lang dun sa ginawa natin last week. So magkakaiba lang yung evaporating temperature na nandito, but the way on how you're going to solve this is, ito lang din yung gagamitin ninyo. So for you to check for the clearance volumetric efficiency, so just use this formula. And then for the displacement rate, ito yung gagamitin. So you have to use K 1.17 and C is 4.5%. So for R22, K is 1.17. For ammonia, K is 1.3, which is based on our previous lectures na din. So based on the graph na mga values for this, graph values for this, ayan, for this. So this is the computed values of the clearance volumetric efficiency and the mass flow rate. So yan din naman yun. Compute nyo lang din and then makikita natin yung relationship between the evaporating temperature and wait lang, medyo may labo pala. Yan, evaporating temperature and the clearance volumetric efficiency with its mass flow rate. So, mapapansin ninyo, yan ay yung mga values na nandiyan dyan. So, clearance volumetric efficiency, percent. So, if the compressor is in use na, then they can check the performance of the compressor. So, next one that we have here is the power requirement of the ideal compressor. So, yung power requirement of ideal compressor, this is just the same kung paano nyo kumuha ng work in the compressor. So, the compression process for ideal compressor is isentropic in nature. Thus, the power required by ideal compressor is the product of mass, kilogram per second, and the enthalpy difference between suction and discharge of the compressor. So, kung mapapansin nyo, this is equal to the mass flow rate multiplied by the delta H. So, same lang siya sa pagkuha ng work ninyo. Well, yung M sub R natin, that is the mass flow rate of the refrigerant. HD is yung H2 natin and HS is H1. So, palaging discharge minus suction yung sa compressor natin. Okay? So, for the, we'll leave this part na lang. And then let's discuss this capacity control on compressor. Can you please read this, Vincent? Okay, Vincent Hernandez, andyan ka ba?
Sorry ma'am, di ko po na capacity control on compressor. If a refrigeration system is operating in a steady state mode and the refrigeration load decreases, the inherent response of the system is to reduce the evaporating temperature and pressure. This change in the evaporator condition results in reduced compressor capacity, which ultimately matches the reduced refrigeration load. The reduction in evaporation temperature. I'm sorry na wala internet. The reduction in evaporator temperature may be undesirable for several reasons. In air conditioning, the coil may collect frost and block the airflow, further reducing the evaporator pressure. Stored fresh food and many other products may be damaged by low temperature. If the evaporator chills the liquid may be freeze and burst a tube in the evaporator. Pati yun ba bang methods used to reduce the compressor capacity?
Okay na, okay na. Nahina internet, tawa ka lang kitawa. Akala mo di ko pansin. Dinahilan mo pang internet.
Sorry ma'am, may ano lang sa top katabi.
Okay, so here are the methods used in order to reduce the compressor capacity kasi okay, kasi bakit again, napaliwanag naman siya on the above statements, no, that the reduction in evaporator temperature may be undesirable for several reasons. Ibig sabihin, we can use the following methods in order to reduce the compressor capacity. And what are those methods? Can you please read this, Trisha Ann?
Oh no! Methods used to reduce the compressor capacity. 1. In cycling, the compressor stops and starts as needed. The method works well in small systems. Back pressure regulation throttles the suction gas between the evaporator and the compressor to keep the evaporator pressure constant. This method gives good control of evaporator temperature, but inefficient. Bypassing the discharge gas back to the suction line usually affords precise capacity reduction, but the method is inefficient and the compressor often runs hot. A preferred bypass circuit delivers the discharge gas that is bypassed back to the entrance of the evaporator. Another method is cylinder unloading on a multi-cylinder compressor by automatically holding the suction valve open or diverting the discharge gas from cylinder back to the suction line before compression. In the reciprocating compressor of two heads, two horizontal lines carrying high pressure oil from the oil pump at the right end of the compressor to hold the suction valves open when the unloaders are activated. The loose inefficient with cylinder unloading is moderated. A step control may be provided which unloads more and more cylinders as the suction pressure drops.
Okay, so this will be explained then in your design project if ever that you're going to do this. Okay, so another type that we have here is the rotary compressor. So this is used in refrigeration system which include a screw and vane type compressor. So can you please continue reading this, Shane, Valerie, Seda?
Rotary compressor. Rotary compressor used in refrigeration system includes screw compressor and vane type compressor. A screw compressor has two rotating elements, the male rotor, which drive the female rotor inside the stationary cylinder. The refrigerant vapor enters one end of the compressor at the top and leaves the other end at the bottom. At the suction position of the compressor, the void is created into which the inlet vapor flows. Just before the point where the interlobe space leave the inlet port, the entire length of the cavity or gully is filled up with gas as the rotation scroll po. As the rotation continues, the trapped gas is moved circumferentially around the housing of the compressor. Further rotation results in meshing of the male lobe with the female galley, decreasing in the volume in the cavity and compressing the gas. At a certain point into the compression process, the discharge port is uncovered and the compressed gas is discharged by further meshing of lobe and the galley. The screw compressor was developed in 1930s and first became popular in refrigeration service in Europe in the 1950s and 1960s. Many screw compressors are equipped with sliding valve for capacity control. It is in the housing of the compressor and can be moved axially. As the valve is open, it delays the position at which compression begins. The capacity can be modulated down about 10% of full capacity, although there is loss in efficiency in the capacity reduction. The best screw compressor efficiency is in the range from 70 to 80%. The compressor is dependent on pressure ratio and the built-in volume ratio of the compressor.
Okay, so next type that we have here is the vane type compressor. So meron tayong dalawa, which is the single and the multi-vane compressor. Saan ba natin makikita kung siya single or multi-vane? So makikita natin siya dito sa vane na nandito. So mapapansin nyo dalawa yung vanes dito. And then dito, isa lang. So we have roller or single vane type compressor. So the components of the single vane type are shown in this figure. So it's a stationary casing cylinder, a rotor or roller, which is a rotating element, a spring-loaded vane, which is always in touch with the rotor, the intake port, and the discharge port. So for the multi-vane naman, the components of a multi-vane compressor compared to single vane area are stationary cylinder, rotating cylinder, intake port, discharge port, and 2 or more number of vanes. So this figure shows a 2-vane compressor physical component. So if magkakaroon pa ng multi-vane like 3, so madidivide lang din yung natin into 3. Kung meron mang ganun. So next that we have here is the centrifugal compressor. Can you please read this, Shane Kalinasan?
The first commercial centrifugal compressor used in refrigeration service was promoted by Willis Carrier in 1920. The largest application is in chilling water to about 6 degrees Celsius to 8 degrees Celsius in an air conditioning system. The centrifugal compressor are similar in construction to centrifugal pumps in that the incoming fluid enters the eye of the spinning impeller and is thrown by centrifugal force to the periphery of the impeller. Thus, the blades of the impeller impart a high velocity to the gas and also build up the pressure. From the impeller, the gas flows either into the diffuser blades or into a volute where some of the kinetic energy is converted into pressure. The centrifugal compressor may be manufactured with only one wheel if the pressure ratio is low, although the machines are generally multi-stage. Centrifugal compressors operate with adiabatic compression efficiencies of 70 to 80%.
Okay, so I have shown you naman kanina, the sample. the video for centrifugal compressor. So this is an equation of centrifugal compressor, but we're not going to focus on this since this was already discussed with you. Saan nga nyo na-discuss to? Ayun, so if ever that you're going to use centrifugal compressor in your design project, then you can base your calculation here. Okay? So for your third part of problem set, you're going to solve problems na nandito. So ito ay 1 to 8, pero so solve nyo lang naman dito is 1, 3, and 8 lang. Para mas konti lang din since maliit na lang din yung time natin. So this is the third part of the problem set. Malinaw ba? So again, 1, 3, tapos itong 8. Clear ba tayo doon? Okay, and then the last part of our discussion is the heat exchanger. So meron akong video about this heat exchanger, pero hindi na natin siya papanoodin ngayon, no? So I will leave that to you to watch. So condensers and evaporators are heat exchangers applied to refrigeration system. So the calculations of this heat exchangers, kaya yan ay karugtong ng heat transfer, di ba yung ating subject. So yung mga computations is heat exchangers was discussed on the previous semester sa course or sa subject ng heat transfer. So since they are called heat exchanger, they have a certain feature in common. So one classification of condenser and evaporators according to whether the refrigerant is on the inside or outside of the tubes and whether the fluid going to condenser or being refrigerant is a gas or liquid. So the gas referred to is usually air and the liquid is water. Depende kung ano din yung working substance natin. Although other substances are used as well. Okay, so the most widely used type of evaporators and heat exchangers are the shell and tube type, which is being shown heat exchanger. So the shell and tube type heat exchangers consist of tubing so arranged horizontally and consider number of passes inside the shell. So the hot gases are condensed outside of the tube while rejecting heat to the cooling fluid inside the tube. So another type is the tube air-cooled condenser, which is consists of fin tubes so arranged to accommodate larger surface contact with the coil. So all of this or both of this and other type of heat exchangers was discussed on the video, but the air intake louver on both sides of the condenser are large enough to accommodate large volume of air. So the V-type 3 rows condenser coil with extended fins are arranged to allow air by exhausted with the condenser fan located on the top of the condenser housing. So the condenser fan expedites the movement of heated air to be exhausted on the fan discharge. So meron again tayong video that was nandito pero iwan ko na lang to sa inyo since pwede nyo naman siya i-play anytime. So this is a 19-minute video. Just make sure to watch this because this is part of the exam then, discussing different types of heat exchangers using a refrigeration system. Clear ba tayo doon? Okay. So, regarding your design project, na start nyo last week, meron ba kayong tanong about doon? Question, clarification, may tanong ba? Tanong? Clarification, may tanong ba? Yes, Shane.
Ma'am, dun po i-upload sa nasa classroom yung ipapasang proposal.
Oo, Neng, pag meron na.
Ma'am, pwede pong dalawa. Isa lang po talaga.
Ano yon?
Dalawa po.
Pwede.
Sige po. Thank you po.
Okay, pwede yun. Any other question? Clarification, may tanong ba? Okay, so for the rest of the time, please watch this video and at the same time can start solving problem set 1, 3, and 8. Problem 1, 3, and 8 for problem set 1.3. Okay, may tanong ba kayo? So if ever na meron, yes, Alvin?
Excuse po, miss. Regarding po sa pagpapasa po ng PSET, kailan po kaya siya ipapasa? Or dun,
Submission is on, dapat Friday yung submission. Pero, meron siguro kayong exam ng Friday. So, ganito na lang. You can do it yung gabi ng Friday. Para it serves as a review for your exam on Saturday. So, bali Saturday ang submission niya. Okay, online yun. Pero pwede nyo namang isubmit ng hapon pagkatas ng exam. Online, di any day na lang ng Saturday. So, kayo na yung Okay? Any additional question? Okay, any question before kayo mag-start? Okay, patams up ako kung clear na sa inyo. Okay. Ayan. So, kung may tanong kayo, sa messenger na lang din kayo magtanong. You can leave the meet and then you can watch first this video and then continue nyo yung pagsasagot ng problem set.
Thank you po.
Thank you po.
Thank you po.
Thank you so much po.
Thank you po.